Hi, boys and girls. So this recording is for Tuesday, December 15th for sixth period science class. What we're talking about, what we've been learning about are layers of the atmosphere and how the atmosphere itself is rather thin but unique and special for planet Earth. As we know, we learned last week that the atmosphere has many layers, starting from the very bottom, looking at the troposphere, working its way all the way up to the stratosphere, mesosphere, thermosphere, then exosphere. And that each layer has its own unique properties, thickness, and so forth. We know that weather occurs in the troposphere. We have a layer of ozone in the stratosphere, which protects us from UV radiation. The mesosphere is one layer which burns up burns up meteors in space. Thermosphere kind of being technically our last layer per se, with the least amount of gas molecules, gets heated up first by the sun. Therefore, it's our hottest layer. And then finally, looking at the exosphere is basically outer space. And so these are the five layers just above our head here on planet Earth, rather thin, but thick enough to keep life here and make life possible. That way we can have an atmosphere or protective blanket which keeps us safe. And so last week we learned about that, how this layer of atmosphere around planet Earth keeps life safe and makes it possible. We also, a reminder for you all, for any of you who did the Ed puzzle last week and you were not happy with your score, just let me know on the assignment, ask me, and I can go ahead and reset that for you. You can take a moment to redo that as many times as needed to improve your grade. So today, our focus is going to be on looking at this pattern happening right here, known as convection currents. So if you look at the model of the Earth, for example, we know that the Earth has poles with an equator in the center, and there's the sun as it hits Earth on its axis. We know that the Earth is tilted, and so it doesn't receive the even amount of sunlight. As a result, we have streams of cold air moving down towards the equator and moving up towards the equator from the pole, the South Pole and the North Pole. Likewise, we also have warm air moving up from the equator outward toward its location. So for today, our focus is going to be on looking at these patterns of warm and cold air moving across Earth's globe. The fact that we have cold air, which is very dense and compact, moves down, falls down, forces warm air up, is what we call a convection current. These convection currents, as Earth spins on its axis, they drive weather patterns, and they really reshape all kinds of global weather phenomena across planet Earth. So today's assignment, if you look carefully, under quarter 2, week 9, you'll see it labeled down here as convection currents. Read the directions very carefully on that. Our goal is to recognize that the sun provides the energy. It is the mechanism that drives convection within the atmosphere. Oceans, it produces winds and ocean currents. So once you open up the assignment, it will look something like this. Keep in mind, this is just part 1. And so this part has been divided up. It should not take you a lot of time. So please make sure you answer all the questions carefully. Look over the slides. Make sure you look at everything very carefully as you're going to use these answers for part 2. And so when you go down to slide number 3, you'll watch the short video clip and answer the questions about, what's the driving force of the oceanic and atmospheric circulation? How does energy flow in the ocean? And describe the impact on Earth if the oceans were removed. When you get to slides 4 and 5, read carefully over these terms. You'll take notes on them by looking at the bold words over here. Put them in your own words. Please don't copy and paste anything from the internet or from the slide. Just put them in your own words, what makes sense to you. Likewise for slide 5. Once you hit slide 6, we're going to just test a little bit of your knowledge after you've done that previous part. Answer these questions. Put down the multiple choice answer, A, B, C, or D. We're getting close to the end, and here is kind of one of the main points as we look at convection currents. 2 things we're going to learn about are land breezes and sea breezes. Here's the land breeze, here's the sea breeze. And as you can see, the warm air is indicated by the red arrows, and the cold air is indicated by the cooler, sort of grayish blue arrows itself. What is causing those land breezes and sea breezes to occur? How can we explain them? So read the questions carefully and explain it in your own words. And then finally, when we get to the end, here is a comparison of those two, and you'll see more about that. And what I'd like you to do is listen to an example of how land can have a dramatic change in temperature throughout the day. One thing to point out as we kind of wrap this up is that we'll talk about specific heat, and that is water itself takes much longer to warm up. The land itself can heat up really fast, but it cools down really fast. Water warms up really slow, but also cools down really slow. This has an impact on coastal regions across the United States and across the globe. So we typically find places near an ocean or a large body of water, near a lake, etc., in the summertime would typically be a little bit cooler in the summer compared to their inland counterparts, just because the water itself takes longer to heat up. But in the winter months, those same locations are typically slightly warmer than the inland counterparts due to the fact that the water holds more heat energy. So keep that in mind. So as you get done doing that, list an example of how the land can have a dramatic change in temperature throughout the day. Once you're done doing that, you're all done. Check your work, make sure your emails are cleaned out. And as always, if you have any questions, just let me know.